Welcome to Session 7 of our Construction Project Management series. Today we focus on the essential development of construction plans, covering critical aspects of planning, technology, and task management. So how do we actually build a plan? It's not a single step. It's a deliberate sequence. We call these the core sequences. First, we have to look at the project and choose the right technology and methods. Once we know how we are building it, we break the project down. We define the specific work tasks. We then have to figure out the interrelationships. What has to happen before something else can start? And finally, we estimate the resources, the manpower, the equipment, and the time required for every single activity. If we miss one of these steps, the whole plan can unravel on site. Let's start with that first step, choosing our technology and methods. We don't just pick the newest or most exciting tools. We have to be practical. We evaluate alternatives based on three main pillars. First is cost and reliability. Does this method fit the budget, and is it proven to work? Second is availability. It doesn't matter how great a piece of machinery is if we can't get it to our site when we need it. And finally, workforce expertise. Do our teams actually have the experience and skills to execute this method safely and effectively? A good plan matches the method to the realities of the site and the crew. Once we know our methods, we have to define the work tasks. You'll often hear the terms tasks or activities used interchangeably. These are the specific, discrete pieces of work that make up the project. Defining these tasks gives us the framework we need to schedule operations. Why is this important? Because every defined activity acts as a bucket. It's where we assign our estimates for manpower, equipment, and duration. It's the essential building block for figuring out the sequence of the entire project. Now, defining tasks sounds simple until you realize that a modern commercial project might involve thousands of individual activities. Managing this complexity requires a balance. On one side, we have the human element. Breaking down a massive project requires immense time, skill, and the real-world judgment of an experienced planner. But human effort alone isn't enough anymore. That's why we rely on system solutions, databases from past projects, advanced scheduling software, and computer simulations to help us efficiently categorize, schedule, and track these thousands of tasks. As we list out our tasks, we also need to place markers along the way. These are our milestones. Think of milestones as the signposts marking the beginning or end of major phases of the project. They indicate significant progress points. A key thing to remember in scheduling: milestone activities have a duration of 0. They don't represent work being done. They exist purely to mark an important event, like foundation complete or roof watertight, helping to keep all stakeholders aligned on our progress. The process of defining tasks isn't static. It evolves. We start with abstract planning, broad functional phases like substructure or superstructure. Then, we drill down. We take substructure and break it into specific subtasks like excavation, formwork, and pouring. Finally, our task definitions become resource-driven. We might separate a task simply because it requires a very specific, expensive piece of equipment, like a tower crane, or because it requires continuous work without interruption. The more detailed our hierarchy becomes, the tighter control we have over the schedule. So we have our tasks. Now we have to link them together. This is called establishing precedence relationships. Why does one thing happen before another? First, there's technical necessity, the laws of physics. You simply cannot erect the steel frame before the concrete foundation is poured and cured. Second, we have spatial precedence. Even if two tasks aren't physically linked, we might dictate that they happen sequentially to prevent overcrowding in a specific area, ensuring safety and efficiency. Finally, there is imposed logic. These are strategic choices made by management, perhaps delaying a task to level out resource usage across the site, even if technically it could start earlier. Once all these activities and their relationships are defined, we need a way to see the big picture. We visualize this chronological sequencing using project networks or graphs. Historically, one common method was the Activity on Arrow, or AOA, network. In these diagrams, the arrows represent the actual work activities, and the circles, the nodes or events, mark the specific beginning and ending points of those tasks. This visual map clearly dictates the workflow and helps us identify which sequence of tasks is absolutely critical to finishing the project on time. This table illustrates a sample site preparation workflow of a construction project. Let's look at a very simplified example: site preparation and foundation work. You can see how one task depends on another. Sequence A, site clearing, is our starting node. It has no predecessor. But sequence B, removal of large trees, cannot start until A is complete. We then move through general excavation, C, trenching D, formwork E, all the way down to pouring concrete F. Each task relies entirely on the completion of the specific activity that came just before it. This is precedence in action. Thank you for watching this session on developing construction plans. For further reference, here are the image sources used in this video.